All right, guys, welcome back. Doing another stream. Gonna keep everything going at like 1 p.m. Pacific time. So I'm trying to get a good schedule going for everyone, even like EU friendly, accessible to, I don't know, every possible time zone. So I just wanted to quickly um, reiterate here, kind of, let me finish setting everything up. Look at this chat, and then get my windows set up. All right, this is starting to look pretty good. So I just wanted to quickly go over where we left off last time. Um, everything was set up with like our 2D tube that was remeshed, and then we were doing like this orthographic top-down view of everything. I'm sorry, I think it was the front view. Maybe it was the top view. So I just wanted to show quickly how this would work even plugging stuff into a 3D geometry. So just how flexible this approach is with even, you're not constrained to just 2D orthographic view because we set everything up in like a procedural fashion. You get a nice effect. You might want to do stuff a little bit differently in 3D, like the way that you're sorting things, or just the like level of density of things. But it's just a pretty nice, flexible approach that any geometry you put into it, you'll get like a somewhat interesting or usable result. So it's just a nice flexible workflow for. Just wanted to show people that it can extend even beyond 2D. So that was my last stream. If you want to find it, you could just go to my YouTube channel. So I started uploading all of my old streams on there. So I think Twitch is like timing out my VODs after 45 days or something like that. So it will delete them. But for permanent storage or just going back to things, I've started putting them on YouTube. And then there's also this older one that I was doing like terrain, kind of abstract terrain workflows. So you can find all of those on my YouTube channel. If you just search for John Coons or whatever, you can find it. And I think I've also been going in and doing some improvements on my channel. If you go to the twitch.tv/John Coons, I started adding my Instagram, Behance, Twitter links, computer specs, and then I started making a Discord. It's not too active, but my plans going forward is like people could post their work in progress, like if they're following along one of my streams, or if you want me to feature any of your work or have any feedback or requests for things you want me to cover in the future. That's a good place for all of that. All right, so get started today. I wanted to do some like OpenCL Pyro, like smoke simulation. So in the past, we were doing Vex over the weekend, but I'm planning just to kind of jump around with these streams, just get into different topics and different areas of Houdini. We'll see how that works out, but for right now, that's what I'm planning to do. So this is like a simple setup that I just wanted to start with to kind of overview my workflow for OpenCL, kind of how things go with that. So I'm just starting with a circle here. I'm adding the point ID, so each of these point numbers is just getting copied over to the ID attribute. And then using some expressions in this transform node, I'm doing, let me just turn real time on. So I'm doing just some kind of procedural rotation or whatever, just with the frame number to drive rotation. And then this trail SAP it's pretty useful. You can do like kind of onion skinning where it will make like multiple copies of the geometry and stuff. But what I was doing, you can get all kinds of interesting geometry and stuff from it. What I was doing is just using it to compute the velocity. So what that's doing is it's taking the difference between, like, depending on how this is set up, with the current frame, previous frame, and then it will add the delta or the difference between those two positions into the velocity attribute. And then you visualize it just with these point trails. And then this attribute here, or this attribute wrangle, is setting p-scale and density. So the p-scale is going to be like the radius or the width of the points. I think if you press the D for display with your mouse over the viewport, then you can get geometry. If you display particles as disks, you should be able to see p-scale. It's possible that that will only work if the points aren't connected to primitives. So if you do delete geometry but keep points, that basically just turns all of your points into particles. And then the reason I say this is because this will visualize the actual like p-scale. So if I change this, you could see just quickly your actual radius that this p-scale attribute is representing. You could also copy spheres to it or do other ways to visualize it, but this is just one of the kind of like hidden, or I don't know, I don't see a lot of people use it, but I find it pretty useful. And then this node right here, I'm just limiting the attributes that are going to go into my DOP network. So this is like a custom kind of like setup that I use for a lot of my OpenCL smoke simulations. I find it pretty fast and pretty robust. I'll just go back here and forget what I had my p-scale at. But basically what this is doing, I'm just using OpenCL toggle on the smoke solver. One thing to be careful about is if you're using like the new sparse solver. So I did upgrade my Houdini to 18. I have some new solvers and stuff in it. But if you're using the sparse smoke solver, it doesn't support OpenCL. OpenCL is basically just letting you do simulations on your graphics card. So if you have like an extra GPU that has VRAM, and I think it will work with both NVIDIA and AMD, but I think NVIDIA tends to work better. Then you can use this OpenCL and it will speed stuff up quite a bit. And then I'm basically just sourcing these particles directly to DOPS using the SAP Geo and then these gas particle to field nodes. So in the newer versions of Houdini, they added this volume source that you can give it particles, but I prefer to kind of split it out and work with it this way. It's more of like a macro way of working with things. And then the other thing, if you middle mouse, you can get like your field resolution here and how many voxels you're making. So when you're doing OpenCL smoke simulations, it's pretty important to pay attention to this. Because if you like push it too hard and you fill up your GPU memory, you'll start getting errors in the terminal, or your just like sims won't even run. You start to get weird artifacts where things just stop moving, and it's pretty frustrating. So just to be careful of that, you could also you do like a new terminal tab or window. If you're using NVIDIA, you're doing Linux. If you do NVIDIA-SMI, this will tell you how much of your virtual RAM or your GPU RAM you're using. And this percentage here will tell you like the percentage of your GPU cores that are being used to like process things. And then down here, it will tell you how much each application is using the GPU memory. So if you have like multiple sessions of Houdini open or other things like that, you could see the kind of breakdown from here. So that you have to like call it each time to update it, but you can also, if you use this watch -n, that will like keep running the same command over and over again. And then you just give it the interval. So like every 0.2 seconds. And then I can do NVIDIA-SMI. So now you can see every 2 seconds it just keeps updating, or it keeps calling the same command, and I kind of get like a live view. Like I could see the numbers actually updating. And then if I want, I could right click and do always on top. And then sometimes I'll just open like a text port or like an unused window space, and then kind of just put that pane on top of it, kind of like it's part of Houdini or whatever, just to get that feedback. And then the last few things that I usually do under cache, I turn off cache simulation whenever I'm running OpenCL, just to make sure that it just slows everything down if you're caching stuff to the RAM, like the computer memory and the GPU memory. And then I'll do a convert VDB, so that will just speed up like the displaying the volumes. And then using these primitive SOPs, I'll just use it to kind of adjust the opacity of the smoke or the density. So this is just a quick way to get a single slider or value to change the display properties. And then you would see here, this should be a pretty high resolution simulation, but it looks pretty blocky in my viewport. So if I press the D key over my viewport and go to texture, you can see under 3D textures, it's limiting the resolution of my volume. So this is kind of a confusing or more technical term, but basically it's referring to volumes as a 3D texture, because it's basically like a 3D image. So your 2D textures is like diffuse maps and open like texture maps that are being assigned to geometry. And then this is like the pixel resolution that it limits these to. So this is the voxel resolution that it's limiting your volumes to. So instead of pixels, picture elements, you have voxels, which are volume elements. So you can see my volume here is above this resolution. So it's getting clamped before it's being displayed. So if I just turn that off, uncheck that box, and then you just have to advance to a new frame to get it to update, then you can see I'm getting the actual resolution that things are. So that's just one thing to be aware of when you start running like higher resolution simulations. And then you can see I'm getting like some of that stepping. So that's another advantage of OpenCL, is that you could go with like pretty high substeps, and it doesn't slow things down too much as long as you're not doing like heavy CPU operations. What I mean by that is like a lot of moving volumes on and off of the GPU. So now you can see it's kind of getting rid of some of those stepping artifacts. And as I'm moving the frame forward, you could see like the GPU is being used more or less or whatever. So it's taking like 20 seconds per frame right now. I'm just going to go in and make this. So I like to use expressions sometimes here, but it can be a little confusing to see. So I just made it a lower resolution, and now you can see we're getting closer to like real-time playback with the OpenCL. So it's not using as much texture memory. It's not using like as many of the processing cores or the CUDA cores, but we're getting like real-time kind of feedback. And then if I want to change the density and stuff like that, I can do it with these. And then I can also change my velocity speed with that. And then because you're not caching to disk, it's usually useful to start making flipbooks. So this will just let you scrub and kind of visualize your simulation in real time. So I could go back in here and increase, we'll just double the resolution of everything. And should be, let's just see what happens with that. So I have a pretty good graphics card in this computer. It's this RTX 8000, so it has like 48 gigabytes of GPU RAM. So I'm lucky, so I can kind of push my simulations and stuff to be pretty high resolution. So like this is using 9 gigabytes of GPU memory to perform this simulation using the graphics card. But if you're lucky like me, you could push simulations to be higher res and get results and stuff like that in pretty close to real time or whatever feedback. So this looks like it's taking maybe like 10 seconds a frame or something like that. But for the results and for the quality and everything, it's pretty nice to have that level of speed and feedback and stuff like that. And then also just being able to do 6 sub-steps, it's a pretty nice luxury to be able to do that number of sub-steps with this resolution or whatever of a smoke sim. So if anyone has any questions, like specifics about this kind of setup or technical stuff, feel free to put it in the chat. I'm just going to keep going with this example scene, maybe like 5 more minutes, and then I'm going to build like a demo file kind of from scratch. So we're going to make a pyramid or make a kind of a piece of geometry, cover it with smoke, and then kind of like reveal it using velocity or using wind forces to kind of like blow the smoke off of it and reveal the shape underneath it. This is a pretty good amount of detail to be able to get without using like extra forces like disturbance and turbulence and all of that. So I'll just go in and make a few more tweaks to this to try to show you some more of the detail you can get. So I'll shrink down these the spheres using P-scale. And I could also use this density to make the smoke thicker or thinner. But I usually prefer just to tweak it post simulation using this. If you do it up here, then you would need to kind of re-simulate everything to see the changes every time you update density. And then I'll just double this resolution yet again. So now we would be up to like 6 600 by 600 by 600 is could be kind of crazy. Could it could crash the GPU, but we'll see what happens. Um, so I'm using these two gas particle to fields. One is copying the density, like the smoke or the visual thickness, into the simulation, and then the other one is getting the velocity. You should be able to see those a little bit better once we move into like the actual working demo. I'll go into that stuff in a little bit more detail. All right, so let's see what happens with this. So I'm just watching these numbers here to make sure I don't fill up the memory, because I did increase the resolution to be quite high, but it looks like we're in good shape. So you'd see that this overall percentage, we're definitely using a lot more of the cores because it's a higher resolution simulation. And then I did reduce the substeps down to 2 to just make everything behave a little bit quicker. So this to me is like the fastest I've been able to figure out how to work using OpenCL. Definitely keeping things represented as particles seems to be the fastest. If you convert stuff to a volume before the simulation, then it seems to take longer because you have to upload an entire volume to the GPU for every substep or every frame that you're simulating. But if you do things like the way that I've set it up here, the particles are a lot less data or a lot more lightweight to upload or to send to the GPU for every frame of simulation. And then it's a similar idea at the end with this convert VDB. You convert your resulting like simulated volume back to a VDB before displaying it in the viewport. That process seems to be a little bit faster. So that's why I've done it that way. So this is definitely like the fastest I've been able to simulate like a 600 by 600 by 600 voxel volume or simulation, which is pretty nice. And then if I wanted to, I could go in maybe my velocity scale, I want that to be higher. Maybe these things, I want them to be a little bit thicker. Then just moving the camera in to see some more of the detail from the high resolution volumes. So I'll kind of leave this running as we start to set up the new file from scratch, and then we could check out the results later on. So disable this guy from floating on top. We'll open up a new Houdini. This is pretty nice PC specs. The processor isn't that great, but I basically took the majority of the money that I wanted to spend on the computer and just put it on the GPU. It seems like even with the new Unreal Engine, having a pretty good GPU should help with that. And then with Redshift, it renders pretty fast. So that's why, to me, like if you're just a freelancer working on one machine, you just spending as much money as you can on the GPU makes the most sense. So I'm just going to start this off with a platonic I haven't been running on Unreal on Linux. I have a Windows partition that I use for other things. I've read that it's not as great to run on Linux, um, but it's also something that I haven't been using that much recently. So this is my triangle or pyramid shape that I'm going to cover with smoke and set it up for the simulation. We'll do VDB from polygons. So this is the better way I've found to convert complex objects to smoke or to volumes. They also have this like ISO offset, but I've had problems in the past with this, like when you have a high resolution object, high resolution mesh, sometimes this one gets messed up with the conversion. Like you can see these streaks or these lines. Oops. So for whatever reason, this is more prone to have artifacts like that. I think that when it's constructing the volume, it's using this laser scan method that produces these streaks. But the VDB from Polygons one is using a better technique, I think, to construct the volume. So that's why I usually use this VDB one. So we're making a density that's one difference or whatever to be careful about is this distance. It's creating a sign distance field that's a little bit different than like a smoke. So that's why you would pick the two of those. I'm just going to open this one up. So you can see this simulation is you get a ton of detail and it runs relatively quickly for like 10 or 20 seconds for each frame, which is pretty nice. So I'll just leave that going in the background. And then I'm going to make another VDB from polygons. This one is going to be like our static object, essentially. So we want this to be a distance VDB. So this is going to be like our hard surface or collision volume. And then this will be our initial smoke. One thing I can do is do reshape SDF. So you can do this like dilate and erode to shrink and expand stuff. So you'd see this, it's kind of like if you ever use the peak SOP, and this guy is moving things along their normals. It's kind of like doing the same thing, but with volumes. And then sometimes I'll use this world space units. So it seems like this can be a little bit more reliable sometimes. Like if I go in and change my voxel size, then the amount that it's reshaping things stays the same. And then sometimes for collisions, I'll do like a final smooth operation at the end, just to try to clean up some of that like stair-stepping artifacts. And then just to keep things organized. Name that static collision. This one we'll name initial density. We'll get going with our DOP network. So I like to keep everything within the same network and try to avoid using shelf tools whenever I'm making my setups, so I can keep things like as reusable as possible. So you can see at the start of the stream, I was showing how you could switch in different geometry with that like dissolving triangle effect. So I like to do the same idea with these smoke setups just to make things as reusable as possible for client work or projects and stuff like that, I like to have a bunch of tools laying around that I can kind of plug stuff in and quickly get results. The shelf tools that will make things, it's just a lot harder to like reuse setups because everything's in different networks, and it takes a lot more time to like re-implement this tool for another geometry or another mesh or anything like that. Then you could use these inputs of the DOP network however you want. I usually set them up this way, but whatever works for you, go for it. So this last input, what I'm doing here is using a bounding box that I want to specify the domain bounds. And I like to do this just so I can visualize and set things up with SOPs. Otherwise, you have to like type in numbers for your domain bounds and adjust it inside the DOP network, and I don't like to do that too much. And then I'll usually use this ends node to make my visualization into a wireframe just with this unroll shared points. And then this guy will be domain bounds. Usually I plug my domain into the third input index or input number for, just to reserve that last spot as always to be the domain. So if we open this guy up, we can see our stuff is churning. You see, even without a ton of like shaping forces or extra noises or wind or anything like that, we just get pretty interesting results. Just because we have such high resolution simulation, like it just reveals a lot more detail, which is pretty nice. So I'm just going to save this scene just in case we crash or something like that. I made a folder for today's date. I'll just call this shape unveil. So we have our inputs. We have our initial smoke. We have our shape that's going to be inside of the smoke. And then we have our domain container, or the bounds. So we just need to set this up inside of our DOP network. So we're going to have a smoke object. And we're going to have a static object. And then we're going to have a smoke solver. You press L if you want to. Sometimes it's nice to have them laid out automatically. Usually I turn off this stuff at the start, my diffusion and cooling rate of the temperature. I'm going to hold off on turning my OpenCL on for right now. So I have this other simulation that's still running. I don't want to start another thing going with another Houdini session and crash my GPU. So I'll wait to do that for now and just finish setting things up. So the domain, to get stuff from this other input, I usually end up using expressions. So we can do bbox and op input path. And then you can use two dots here to get like the relative path of this DOP network or this node. And then the input index 3, which is the fourth, like 1, 2, 3, 4 input. And then I want to get the d underscore x size. So that's just like the syntax or whatever you need to use for the bbox. Like it always has that d underscore. It's like a legacy Houdini reason or whatever. So I'm just going to use the tab and paste those into the other components. And then for center, I can do a similar thing, but instead of bbox, you just use this centroid expression. And then instead of size, whoops, just do dx. So this is what I mean by now you're able to define these numbers using SOPs. So if I want to go up here, do a transform node, I want my domain to be, maybe I'm just testing stuff, so I want it to run quicker. I could do like a slice of my simulation and just have that set there. I could toggle it on and off to change my resolution pretty quickly. So now we need our initial data. So I'll keep using this op input path. That's what I mean by keeping things procedural. So setting things up like this, I can wire other things in and all my expressions update, my simulation updates automatically. So I don't need to keep relinking to different SOPs. I also like to put things into temperature. So with the buoyancy, that will cause things to rise. If you don't have anything in temperature, you can see it's just kind of staying, everything there's no forces or whatever. Now we need our static object. And for collisions, instead of right intersect, I use this volume sample. And then under proxy volume, we can do our op input path again. So this is, whoops, this is going to be 1. If you want to double check, you can middle mouse on these. So, because I've labeled these properly or just descriptively, I can just very quickly be sure that I've chosen the right number, because it does get confusing going between like 0 and 1 based indices or inputs or whatever. So I think everything's good. The last thing I like to do is turn on solve on creation frame. So I just make sure that the simulation starts like at frame number 1 or whatever, instead of sometimes it waits a frame to kick in. And then under visualization here, if you turn on collision, that's how you can get this thing to show up. So you don't always need to specify the SOP path and stuff like that. Here I'm just directly referencing the VDB using the op input, and that will be pretty quick. And you can see everything's like a super low resolution. So I'll just go back to my properties and make things a little bit higher resolution. So we have like a shell of smoke that's encapsulating our actual shape. And the spacing, we could adjust that procedurally with our erode or our reshape SDF if we wanted to. Then I'm going to turn off my cache, because I'm going to plan to do this with OpenCL, so I don't want to waste time caching the simulation to disk or to the RAM. And then under my object merge, you just need to tell it which fields, or like you could add more fields to import back into SOPs. And then I like to convert that back to VDB. So DOPS will always work with volumes as like a dense or a Houdini volume. You would see that it just says volumes right here. So that means it's a Houdini volume. But when I convert it to VDB, now you could see it says VDBs. So that's a sparse volume. So you can see already this is less voxels than it is up here, because it's able to eliminate empty space. So instead of being like 41,000 voxels, you go down to 4,000. So that just makes it more lightweight or quicker to work with. And then the last thing I like to have is just this primitive. This is kind of a hack. It's like just a quick way of setting the volume opacity or the thickness. And then whenever I'm simulating or working with volumes, if you don't have any lights in your scene, it will just assign a headlight to the camera, which is basically giving you the same result as like what the alpha channel is, because everything is front lit. You don't really get any shadows. Um, so I'll usually just add a light to my scene just for like visualization purposes. You can just move this up, off at some angle, and then just to be sure that the distance like doesn't matter, I usually turn off attenuation. So I just want this to be a directional, just a light from some direction, so I get some shadowing. So you'd see the difference with that on or off. So I'm ready to get started with OpenCL in this current scene. Actually, I'm going to let this simulation keep going for a little bit. What I'm going to do is start setting things up for the particles. So right now, the only force that we have is the buoyancy, which is a pretty boring force to use. What I want to do is have control and be able to blow the smoke off of this shape. So I think a good way to do that, I'll do this remesh. And just get more. So what I want to do is have points evenly distributed across the faces. So instead of just having it constructed out of 4 points, now we have a pretty dense representation. And then I think this, forget the name of this node, but there was like, I think it was attribute fall off or something like that. It might have been, I don't think it was fade. It was like doing something across the surface of geometry. Maybe I'll just do a different one. So I know with find shortest path, you can use this to generate a cost attribute. There was another one that I was thinking of. I don't know, I can't find it right now. It was basically like computing the surface distance. Maybe I'll have to think about it later. So with this guy, we can use it to compute just a cost. So I don't need to output paths. I'm not too concerned about that original number. All that it needs is a starting point, so you can give it 0. And then this will generate a cost attribute. So if we look at it here, it's basically a floating point number. It's kind of like a mask. You can do a lot of interesting things with it. So if I use a color SOP, I could use this to do a visualization of it. If I do ramp from attribute and I do cost, we turn off my lighting. So you can see I'm getting like a gradient mask from my starting point. And then if I want to procedurally change my starting point, what I could do is just sort the geometry from like a direction or a specific point. I don't know, I'm not getting my transform handle. But this is a different way to like, you just type in your origin, and that's where the 0th point or the starting point will be located at. So we have now a gradient, like a grayscale. And what I'm gonna do is use this as like a mask to inject or to choose where particles are added to the simulation. Like when I want my wind to start and when I want it to end. So if I do something with wrangle, um, what I could do here is set the color to the cost. And then instead of going just directly from the cost, like if I do the absolute value of cost minus 0.2, you could see I have this ring, and I can control where that ring is by offsetting my cost by a certain number. So using this attribute now, I can move that along the geometry. That's pretty nice to be able to do that. And then if I want to, I can remap this using the fit function. So instead of going from 0 to 0.2, I can go from 1 to 0. So now we have like an alpha channel. So I'm basically going to be using this mask to only blow or add velocity to my shape in that selected area. So I'm getting ready to start running or messing around with OpenCL. So I'm just going to end this previous simulation. You'd see how quick the results are running stuff using OpenCL. You just get super quick results per frame. So I'm just going to close this other scene so it doesn't slow things down. And make sure we recovered a lot of our OpenCL memory. And then if I do another window, I could also do like htop. So this would just give you your CPU usage and RAM usage. So we're back to being pretty optimized. So now what I'm going to do is add my velocity. So we have our particles. Then what I want to do is just add some velocity to it. So I usually use curl noise for that. It gives you like a pretty good swirly or interesting kind of directional pattern. And then if you want to evolve that over time, I like to use this vector to vector 4. So that will just swirl things around nicely, kind of like a wind or a breeze. And then, because like I was saying, I only want this velocity to be added in that area, what I can do is just multiply it by the color. So this is kind of like you have your alpha channel and you're pre-multiplying your image by the color. You can do the same thing with the velocity. And then I just want to create a p-scale. So this will just be like a radius for my particles. Whoops. It's like 0.1 might be a good starting point. Then I could add keyframes to this. Maybe I'll just type in time to get started. I don't have to spend time making keyframes or whatever. And maybe my p-scale, I also want to multiply that by the color. So what I was doing here is just the red channel of the color. And then the last thing I'll do to speed things up even more is delete the points where the color value is less than 0.001. So this will eliminate the total number of points I have as well. And then this will be my particle source for DOPS. So do this. All right. So we have all of our inputs now. Now we just need to get the particles into the simulation. So I usually use this SAP geometry and apply data. So my SAP path is going to be up input path 2, I think. All right, so now you can see we have the particles inside of the DOP network. But if I play my simulation, you can see that they don't move at all. So you just need to, I think for this time, you need to make sure it's set always. And then this will keep evaluating or keep updating the points every frame. And then to actually have these affect the smoke simulation, they have this particle to field node. This one's pretty good for quickly like converting particles to volumes, but I think it happens on the GPU, so it's a little bit faster than doing it just within the like rasterizing them at the SOP level. So my destination volume will be vel. My geometry here, you can see this is set to geometry, so that's good. My attribute is going to be V. You don't want to do extrapolated for this case. That's like something to do with the flip solver. And then the calculation, I want to add it to velocity. And before I turn that on, I just want to make sure that my buoyancy is off. So you can see there's no forces before I turn this on. And then when I turn it on, now things are actually moving, or they're getting like blown around by the particles. Let's go into my viewport and just make sure my textures are set up nicely. I'll turn off this limit resolution again. Sometimes you want to make sure, like, I already have this stuff set up by default. You want to make sure HDR rendering is turned on. Transparency, like medium quality is good. And then you want to make sure this is like 16-bit HDR for volumes. And then usually what I like to do up here is I'll pin my view to this network SOP level, and then I'll still go inside and mess around with the simulation. For whatever reason, inside of here, like the actual scene lighting stops being applied to things. So if I pin my viewer at this SOP level, then I can still get good results quickly without having to like jump in and out of the DOP network and everything like that. So you can see we're getting a pretty interesting result of things getting sprayed around. But it's looking like a little blobby. So what I'm going to do is go up to my remesh and make things even closer together. And then that will let me reduce my P scale to be even smaller. So when you're adding a force, you have smaller particles. Your velocity that you're injecting gets more like detailed and less blobby overall. So this simulation now is pretty low resolution. So what I can do is just go into here and reduce the division size. So now you can see we're at like 350. That's a pretty good. Usually I like to work around like 300 cubed or whatever, 300 by 300 by 300. That's a pretty good, like, when you're working with OpenCL, that's a pretty good like balance of speed and responsiveness. So I can turn OpenCL on, and then under advection, I usually like to switch this to the BFECC, and I like to switch my method to RK3. Um, so these are a little bit slower, but when you're working with OpenCL, it's kind of like negligible for the speed difference or the speed in quality. Like you get a big quality boost, but the amount of speed hit is pretty low. So what I can do, I might want to pin this guide back. So when I'm playing it back, I can get like better feedback of what my GPU is actually doing for this case. So it's might be a little bit slow. So some things that can slow it down are the amount of particles that you feed into the simulation. So if I go a little bit higher with this remesh, and then if I make my p-scale a little bit bigger, this should get my speed going a little bit faster. So it might still be a little bit too slow for, I'm just setting things up. I don't want to, I'm not expecting like final production quality yet. So what I can do, I have a few options. I could make my simulation a lower resolution, or I could also do what I was talking about earlier and apply this transform to my domain bounds. So I could just shrink everything. And then that's a quick way to kind of crop in on an area of a simulation and get quick results, see how your forces are behaving, see what kind of results you're getting, and then kind of move forward from there. And then if I wanted to more quickly like preview how things would be, like how a final render would look, what I could start to do is just like composite this geometry together at a SOP level. So I could use this peak node to apply a similar kind of erosion or pushing inwards of things. And then I can quickly kind of move my, my settings around and stuff like that. So I like to work this way because it just lets me really get quick. It's almost like you're working with a real-time engine, like you get really quick feedback on what your final results are going to be. Sometimes working with volumes with Houdini, you'll waste a lot of time caching things out to disk, rendering it. You waste like a day doing those steps, and then you don't like the result. So I'll usually try to get the quickest feedback of like what my final results are before I move on to the other steps like rendering and doing all that stuff. So I could see here my smoke's getting blown, but it's not all moving like in one direction. It's just like getting kind of stirred up and then it's just lingering around. So what I want to do is get my predominant direction here of the cost. So I can do that. There's a pretty neat kind of hack way to do that. So if I set my color from the cost right here, there's an interesting feature of this polyframe node. So instead, usually you use this to find like normals and stuff from the geometry, but it also has this setting here that's called attribute gradient. So if I use that, it will basically assign this will assign a direction based off how these values are increasing or decreasing. So because my cost is getting higher in this direction, all of my vectors are then pointing in that direction. So what I can do is promote this from a vertex to a point attribute. And then the new name, I can just make it V for velocity. So now you could see with my velocity vectors being visualized, we have all of these pointing like along the surface of the geometry. And then what I can do is just use this attribute copy to kind of like transfer them over. So now we have our velocity vectors copied from this data stream onto this one. And then with my VOP here, instead of simply overwriting the velocity, what I can do, actually I still want to apply the mask at all times, but I'll just add it here. So we'll add it to the existing velocity. And then if I wanted to, I could change the scale of like directional vel or curl noise. So I could scale these two forces kind of independently before they get added to the final velocity vector. Then at some point I turned off my lighting, so I just want to make sure that's back on. I think I turned it off when I was visualizing like the color of things. So now you can see, because we have this directional force, we're able to get a nice coherent structure or pattern to the just the direction that the wind is blowing. So getting some more interesting kind of stylized results instead of below. Before it was just like a mess. Everything was just getting stirred up. One thing I might want to do, like it's a very thin shell that is pushing everything, like just a sliver of the actual smoked area that we want to blow around. So if I use this attribute randomize, this is another one that's kind of like a hack. It's not really the way that this node was intended to be used, is when I say this is like a hack. So we can randomize the point position, and then we want to do that like inside the sphere. So this is moving things outward in a spherical distance. And then instead of overwriting or setting the value, we can just add the value. So when we look at what this is doing, it's just jittering the points or disturbing them. But you can apply these more interesting like distributions using this node instead of using like the other alternative. People usually use the jitter, but sometimes this randomize, you have a little bit more control over things. Go back to inside sphere. Maybe we do want some more points here. And then I'm just going to do an add at the end to go into only the particles. So now if we visualize this, we can see what kind of results we're getting. Another thing that I can do under options here, I can update the seed every frame or every time step, or like every time the time changes. So now this jitter result will be different every single frame. So we have this random kind of like little bees or whatever going in and like injecting velocity into different areas. So the reason I was doing those steps is to try to blow off, like we have a thicker area of smoke, and some was getting left behind before. So I just want more areas of the smoke to be getting pushed around by those particles. So you can see we're clearing off more of our object now. We could increase the P scale a little bit more and kind of work with that in tandem to this jitter. If I wanted to, sometimes what I like to do is copy spheres to these just to visualize their size and use the template flag. So now we have a pretty good visualization of their like P scale, what areas they're affecting, and how they're moving. We could keep an eye on GPU usage down here. The one drawback with doing this is just that they do, like, the display doesn't composite the wireframes that well on top of the actual smoke. So we can see now one of the issues we're getting is like we have these pressure fronts that are building up. Sometimes people want this look. Sometimes art directors look at it and they think it's unnatural. Usually people think it's unnatural because in the real world there's like other forces here that would be breaking up these big pressure fronts. We have the advantage here that we can hopefully break them up just by increasing our kind of like ambient or curl noise. So I think things are looking a little bit, things are getting a little bit closer to like a final result. So I'm going to start kind of like setting things up like it would be for a camera. And then I'm going to start using this flip book a little bit more. All right, should be good with this. So now we're getting a better, more natural like peeling back of the smoke. So you can see using this workflow, the reason why I spend extra time like figuring this stuff out is because now I can run these kind of like production quality, high quality simulations. We're already doing like maybe 1 second of animation per minute of simulation time. So we're just able to get like super fast results or feedback of our simulations. So you'd see maybe our directionality is either our direction is too strong, our particles are too big, or we have too many of them. Like all of those factors kind of work together to make this stuff appear to be too strong. So what I'm going to do is go in and make my particles smaller. Then I'll go in here. I'm also going to change my sort method to this. So I'm starting at the corner or the tip of the triangle, and then things kind of go around like that. I'm also going to make my noise a lower frequency just by multiplying the position down. I'm going to reduce the frequency of this last component. So that's how quickly things evolve over time. Let's give that a try. Let's see what happens. So I'm also going to go in here and maybe make my resolution a little bit lower just to move a little bit quicker along with the results. I'll turn off the cropping of my simulation domain. So that's where our forces are kind of looking like. We'll give this, I'm just going to move this light around a little bit. So we kind of have this like rim light effect or whatever. So let this simulation run a little bit, but if anyone has any questions, feel free to pop into the chat. So it looks like my force might be a little bit too low. It could be nice. Kind of have this balancing act, like if you throw too much force at things, you get the pressure fronts that don't look too nice, but this is kind of, this might be a good balance. We'll give this a second to finish up. I'll be right back. All right, so it looks like these things might be working pretty well. It's leaving like a little bit too much smoke behind. So I'm going to go in and just make, I guess, make these just a little bit bigger and make this division size a little bit lower. So that will make sure that we have more points overall. And then might want more curl noise and maybe we'll try like higher frequency for the noise. I don't know, I might also make this thing, I'm going to change the size of the distance that it's being eroded inwards, just so we have like a thinner shell area at the end. And then I can just link these parameters to get a better match between the two volumetric and the surface kind of based methods. So let's see what's happening here. Getting some interesting stuff on the other side. Um, so what I'm going to do, I'm going to change this to be a little bit bigger of a gap. I'm going to go in here and just change my offset so I have like a different pattern for my curl noise. Then we'll start to like set up a camera angle. So hold control and click there just to make a camera from that view. And then run another flipbook. All right, so I'm going to make some quick updates based on those results. Just do another different offset. I'm going to make this speed a little bit slower. So the wave that's moving across the whole shape will happen at half the speed. And then my overall directional velocity will be half or 3/4, and my curl noise, I'm gonna take the 1 off of that. I might take a new camera angle. So I'm gonna try something like this. Unlock the camera, see what happens. So at the end, we're probably going to want to expand our simulation container or the domain just to get rid of this cropping that's happening at the bottom. But for right now, we're happy to have it because like we're getting faster simulations because of it. So this is more of what I wanted to see, is like this leading area starting to like see it get peeled off like that is pretty nice. So this is going to be a pretty interesting transition effect to kind of go from a smoke or a cloudy material to reveal. You could put like a nice gold shader on this or a plastic or something like that, like you're unveiling a new product or something. You could do a logo. Could be a lot of different things. You could see down at the bottom, we're still pretty good with like memory usage and things like that. So what I'm going to do is go in here and increase my resolution. So now we're working at something like almost 400 cubed voxels. What I'm going to do is reduce the overall number of particles. So if I visualize them here, just want less of them. So sometimes having less particles will give you more detail in the end because there's more gaps between them. Like if you have too many of these and they're all overlapping, you just get a pretty blobby effect. And then the number of particles that you have also like slows down your simulations. Then I'm also going to get rid of this jitter per seed. So I'll try this and see what happens. The other thing you can do that's pretty nice, if you use this performance monitor that's built into Houdini, um, and then you use this with OpenCL. Like, it does a good job of breaking down which nodes or which part of your simulation is using the most time, or the most is hitting your performance the most. So you get these two guys side by side, and you have like the complete breakdown of all the information you ever needed. So it looks like these low level gas collisions and stuff like that is taking up the most of our simulation. This temperature inside collision is a pretty long step. Um, I think what that's doing is like masking out the inside of this shape, and deleting any temperature or density or whatever that's inside of the cube, or the pyramid. You'd see now making my particles smaller and having less of them, we're getting more detail. You'd start to see more shapes, more negative space, and stuff like that inside of my smoke. So it's a little bit nicer. It's pretty good. So it's possible I made them too small. Like, I still want to retain some of that line. Like, it's a solid transition. Right now it's like leaving behind too much of the smoke. So I either want to make more particles, make them bigger, or make them like a stronger force. So let's go ahead, stop this. So you'd see these red highlights and stuff like that is added from the performance monitor. So when I click this, now you can see like a visual breakdown of which steps or which nodes of the simulation take the most time. Even nodes like inside of digital assets will get lit up too, which is a pretty nice thing to have happen if you're really like troubleshooting or trying to figure out what steps are taking the longest. So this is what I was talking about with these steps here that might be causing more time. So if I like completely disabled collisions, that would cause things to go faster, but I would lose like my velocities wouldn't look as nicely as they blow around that shape. So I want to leave them on. Let's make my particles a little bit bigger. And yeah, I don't know. Maybe this like offset per frame was pretty nice. And then maybe this scale will reduce that. I'm just going to delete this profile. We'll clear that out. And I'm going to start trying to move a little bit quicker. Because we're already like an hour and a half into the stream, so I don't want to waste too much time finessing things or whatever. So you'd see if you ease back on the overall resolution, you get a lot closer to like a real-time simulation, which is pretty nice. So it's finding like a balance that works for you, of resolution and quality and speed and stuff like that. Ideally, you want to be able to kind of iterate and feedback as quick as possible. So when you're just trying to get a good result as quick as possible, you want to be able to like make a change, see what the result of that change is, and then like reevaluate and make a new decision like as quickly as possible. So it looks like things are still getting left behind a little bit too much. So what I can do is increase my directional velocity. Maybe this amplitude, I'm gonna up this time-based like evolution frequency a little bit, and I'm going to reduce the overall frequency. We'll try another. So you can see here things were just moving a little bit too slow at the end. So hopefully with these new settings, we'll get a little bit faster, or like things will vanish completely off of the shape. All right, so still doesn't seem to be working that well. Go a little bit higher with my directional velocity, a little bit lower with the noise, and maybe we'll get a little bit more particles. I'm going to make this jitter a little bit thicker. So you can see just how much more efficient working at a lower resolution can make you. You could imagine if you're doing like a CPU-based Pyro simulation, I see a lot of people working, every iteration is taking them like 6 hours. So if each of these like previous tests that I ran each took 6 hours, that would waste like a day or 2 days of my working and computers kind of time. So to get the kind of like stylized moments that I want to, I really need to be able to work a lot quicker. Otherwise, you just don't have enough like time and adjustments to be able to make to get the results that you want to. So now that I'm starting to get a little bit better, like art direction overall, things are going where I want them to go. I can start to work at a lower resolution or lower division size, which is like a higher resolution. So I'm going to go back to 0.005. I might want to go a little bit denser on my overall like display density. I'm going to try to get this light a little bit more overhead. So I want to be able to see more of it like bleeding onto this side. And then I don't want to, I don't know, I don't want to see too much of the shape inside of it. But this is also just like a GL preview, so I don't need to worry too much about that until we would do like the actual render or something like that. So let's see what's going on. We've got our simulation. We might want to increase the padding of the domain a little bit more. Visualize that. So I just need to move my pin back into the network to be able to see my wireframe. The problem was when I made my camera, it snapped the view to be pinned at the object level. So let's go ahead and see what we get. These results will take a little bit longer because I increased the resolution to kind of be back at a higher resolution where we were before. But I think the results should pay off. Ooh, got all the homies coming in. So this could be an Illuminati style pyramid. So you can see we're getting like overall the same kind of animation, but just the resolution is a lot higher. So that's the ideal balance of like previewing and dialing in forces at a low resolution and then moving to a higher resolution to do like your production or final quality results. So the overall idea of this project is like to take a shape, cover it with smoke, like a blanket, and then using particles and like OpenCL, I'm transitioning to blow the smoke off of the shape or to reveal what's underneath. So I have my GPU monitor pinned right here, like to make sure I'm not using too much GPU RAM. And then this percentage right here is the like CUDA cores or the GPU clock, like how much the actual processor is being used, and then this is the memory of the GPU. So this overall timing, it might be a little bit too slow, but if you if you wanted to, you could retime it like after the simulation to get a better result. There's also more things you might want to add, like disturbance or things like that to break up these bigger kind of like bubbles. Sometimes it's nice. This is more like you have ink in water or something like that. These like big kind of jellyfish structures, but it's more up to like your personal taste or your art direction or whatever like that. And then there's also a bunch of things you could do like post simulation. Like I could save out the velocity for this, and then advect particles, like bigger particles through it to get more of stylized, like bigger spheres or something like that. Could be little shards of metal that is like transitioning that way, getting rid of them. I kind of like the composition and overall directionality, like keeping things going from one side of the frame to the other. It's starting to be pretty nice. I'm trying to slowly steal viewers from the side effects. I see they've been doing streams, broadcasting stuff all day. I'm trying to see if I can steal some people from that. I don't know. We storm in there and brigade their chat and steal people. So we're starting to get pretty good results. Just overall, the time seems a little bit slow. Oh yeah, I'll watch you on Thursday. I haven't seen you stream in a while. Have you been? Are you just getting back into it, or you've been still going regularly? Mr. Mr. Shades. All right, so I'm gonna make some tweaks here. I'm going to let's go higher division size or like a lower resolution overall. Oh, you're on the side effects stream. I'll definitely be watching you. It's the big man, the celebrity in the chat. Should give this. I don't know if I can VIP people from here. Let me see. How do I do it? I don't know if I have the moderation capabilities. Maybe I can't VIP people because I'm not. I don't have a high enough Twitch profile ranking yet. I think you need to be like an affiliate or something to VIP people. Um, so what I wanted to do was just make this uh, time a little bit faster, so things are moving across our shape faster. We'll speed that up, and then my directional velocity can be higher, um, and my curl noise will be higher. So let's see what we get here. So when is your, let's see what's going on here. So we have Mr. Shades of Orange going in the chat. Where's their schedule? Their website is never, I can never find what I'm looking for on it. This is news? Yeah, so it's this Hive worldwide. Let me see what's going on here. Whoops. I think I had it. Oof. So you're going Thursday? Which time is yours? Nine a.m. All right, I'll definitely be there. This is all you. This is Eastern time. This is going to be like 6 a.m. for me. Set the alarm. So I think when my resolution becomes too coarse or like it's too low, then I'm getting these artifacts. But it looked like when I switched to the higher resolution, that was fixing that problem. So what I think I can do, maybe I'll make these P scales a little bit smaller again. I think that might be all I need to do for right now. I can start adding some more forces maybe. This vortex confinement can be, it's like a lazy way to add more detail. Usually I do this, I'll copy the OpenCL parameter and then I'll paste the references or whatever, and then just put it into velocity update. And I don't know, 2? If you're lazy, you just make this pretty high. It will give you some more details, but it can kind of ruin the motion sometimes. Like if you rely on it too much, things just kind of like spin around forever and it looks a little bit bad. But for right now, I'm just going to add it as like a quick way to introduce some more detail into things. What do you, which was your, what kind of stuff were you going to be covering? Ooh, you're doing neural video style transfers. This should be pretty exciting. So this is like a GAN style transfer type of thing? You use the motion, the optical flow node, or you have your own custom stuff that you've made? So you'd see maybe my curl noise or my confinement is like, it kind of makes everything look a little bit too much the same, but maybe it's okay. Let me see. So I think I want my my particles bigger. Keep wanting to make them smaller to have more detail, but I think that that's kind of ruining things. So I'll make them bigger. I'm going to make this confinement smaller, just one. Um, then I'll make the overall resolution higher. Um, we'll start a new flip book and see what happens. I'm just going to leave this started. I'm going to take a quick break and I'll be back in a minute. All right. So looks like this is why I kept wanting to make them bigger, or why I ended up making them bigger, just to keep this clear kind of transition line going from like undisturbed to fully revealed. I didn't really like it when it was like too messy before. Um, so when I do make them bigger, it's kind of a disadvantage to get these bigger jellyfish kind of shapes. Um, it's possible tweaking that curl noise frequency. You kind of clean that up or fix it a little bit. But for right now, I think, I don't know, this stream has been going almost like 2 hours, so I'm just going to keep plowing forward, not going to fiddle with things too much more. You can restream your own side effects presentation, Shades of Orange. You can raid. I don't know why, but I think side effects should be. They need to make like a Twitch channel and restream or broadcast to both of the things at the same time. It would be nice if like side effects had a channel and they just raided people and hosted like all day. Yeah, so these guys here are getting like a little bit too obnoxious. It's like eggs, Easter eggs, or too many mushrooms. But like I said, I'm not going to be worrying about too much of this stuff because the stream it's getting close to like 2 hours. So it's possible, like I could either make the particles smaller, um, or just the overall velocity scale to be lower. But for right now, I'm just going to leave this, leave it the way it is. So if we do want to start getting things ready to like cache it to disk for rendering, I'm just going to go over those steps, um, save the file, put the stream up, and leave people there, and then possibly later on we'll pick this file back up and like move on to post processing, rendering, and those kind of steps. So I'll cancel the flip book for now. Get rid of this because we're done with like debugging OpenCL stuff for right now. Do an object merge. So this is something else that's kind of a hack that's It's like a tricky way that I do sometimes to get the velocity from a DOP network. So what this is doing is it's saying any object or every object in the DOP network that has a velocity field, fetch it or retrieve it. So sometimes I use these object merges instead of the DOP fetch. It's kind of like a hack. Then usually convert to VDB just to keep things the same format. And then you can merge the two of these. One thing you can do sometimes is multiply, create like a mask and multiply the velocity by the density to save space on disk. I'm not going to set that up right now. The other thing I like to do with the velocity is just make sure using the same primitive, you can adjust visualization and make it invisible just to hide it from the display. And then just keep using this primitive, just keep putting it down, more and more of them. The last reason I like to use it, volumes, VDB, and then write 16-bit floats. So this will make the data that you write to disk take up less space, essentially. It doesn't affect volumes in your scene at all. Like, it's just the way that it's being stored. It will use the half precision or half float precision. I'm going to save the scene, and then I'm going to set up a frame range. Maybe 96 is a good one. I can leave all of these the same. Because this isn't using too much OpenCL memory, hopefully I can get it going. Save the disk in background. So you can see my background render has started. If I go to the scheduler, I can see it there. I can also go to my terminal. You can see now I have this H batch that's also going. So that's how you could visualize even using the same kind of statistics, NVIDIA-SMI. You can use that also to troubleshoot your background processes to make sure, like, I'm getting close to going over my memory limit, but because my graphics card has so much GPU RAM, I can be a little bit more lazy with that kind of stuff right now. I didn't know Side Effects had a Twitch channel. Are they restreaming their stuff on here? Are they doing their Solaris presentations? It just seems to me like they don't use it too much. Yeah, I think it would be nicer. Like, their community outreach person needs to start getting more active on Twitch, like hosting other Houdini streamers and stuff like that. So because I have this stuff going in the background, I can read it in as my simulation is going. So I'll just do this paste relative path. So depending on the size of your volumes or things like that, it can still be a little bit slow to read back in. Another thing that can cause it to be slow is, like, maybe it's trying to display all the volumes. So if I only keep the density volume, sometimes that speeds it up. If you're just getting quick visualizations, you might want to turn on your 3D texture limit. And then now it's just slow, probably because of, like, disk IO speed. loading these volumes from disk into the scene can sometimes get a little bit slow. So these are like 500 megabytes per frame. It might be a little bit slow. Um, that's why I was saying if you mask the velocity volume, that will save space. You could also just disable velocity, like if you're doing quick caches. So maybe I'll do that for right now. So this should speed things up a little bit more. Not only on the like reading stuff back in, but also just caching stuff out. It should generally be faster because it's like less data to write out. I'll just kind of start to wrap things up here. Just try to clean up our scene a little bit. So I'm just trying to organize stuff. Maybe I want to keep that. I have like a bad habit of keeping these extra visualization nodes around too long, and then people open the file and they're like, what are all these things? Why, like, what are they for? It gets too confusing sometimes. Let's do this, input shape. So again, this is another setup that I'm trying to do to keep things fully procedural. Like, again, if I wanted to go in with this pig head, just make sure it's not too big. So you have to be careful sometimes with the size using like the DOP network, because because everything's procedural, I might make another domain that's just too big and crash the GPU. The helpful way to do this is like the match size node. So if I want to make sure that this pig head is going to be relatively the same size as this thing, you can do it like that, and that's pretty helpful. So if I were to switch this over and cache everything out again, like I could get a simulation of the pig getting the dust or the smoke blown off of him. But I'm not going to do that right now, just for the sake of time. But that's just a kind of quick overview using OpenCL to simulate stuff. Hopefully this is a good way to get people started with it. It's definitely worth it just for like the speed, the feedback, and the results and everything that that you're able to work with for simulating volumes. I think it's still faster than the sparse simulation if you're like efficient with the way that you set up your domain and plan things out kind of ahead of time. And then just using this particle to field, I've found is generally a lot faster than using their built-in source. Like their shelf tool will basically convert the particles to a volume in SOPs and then source it into DOPs. And I've found that that's a lot slower than using this node. And then, so right now I kind of disabled that texture, unclamped texture, whatever. So if I want like more of a higher quality, I can turn that back on. And then if I wanted to do another preview, I could do a flipbook just with that thing. So if you wanted to, like you could already kind of render this or use this in a comp if you were like planning things out, or you just wanted your team to get started like treating this or mocking it up for a client. You could also give your comper like this initial thing to get started with, and then dial in your render, your look settings and stuff like that. but this is just by far like the quickest way I've found to make smoke simulations and kind of work with them. So you'd see under like 2 hours, we already have something presentable, like to your supervisor, to a client, or you could show someone and they kind of know the direction you're heading in. But a lot of times with Houdini, um, people starting smoke simulations, like 2 days later, someone, the supervisor will come by and they'll be like, what do you have? How's it look? And they'll, it's just like the window has the interrupt thing, and it's like the solitaire game where it's all smeared all over the screen, and it's frustrating for everyone because it's like it shouldn't take this long, but from what I found, there isn't the best information available online in terms of like efficiently working with OpenCL and getting good results. There's like a lot of little steps like that terminal command or whatever to properly like visualize everything. It's kind of hidden. So that's what I was trying to hopefully point people in the right direction with this stream. Hopefully you guys get some good results. I'll be putting the scene files up in the description of this VOD, uploading it to YouTube and everywhere else. So if you're seeing this on YouTube or anything, come over to the Twitch channel, give me a follow, and you can hop in the chat the next time I do a stream. So we'll probably be moving on to like rendering or post-processing or just different options. Maybe tweaking the simulation a little bit, but I'll just be picking this file up in the future. So hopefully everyone had a good time. Hopefully everyone enjoys or finds this useful. I don't know when my next stream will be. Trying to keep things regular at 1 p.m. Pacific time, and then do like 3 or 4 of these a week. Definitely Sunday. Tuesday seems to be pretty good. The other days are kind of up in the open. So I'll be like making a proper schedule and posting it on Twitter or somewhere like that in the future. But for now, I hope people find what I'm doing helpful. All right. Talk to you guys later.